a solar power station in space, how it would work, and the benefits it could bring to mankind, of course. This is by The Conversation on phys.org. It's by Jovana Radulovic. The UK government is reportedly considering a £16 billion proposal to build a solar power station in space. And yes, you read it right, space-based solar power is one of the technologies to feature in the government's net zero innovation portfolio. It has been identified as a potential solution alongside others to enable the UK to achieve net zero by 2050. But how would a solar power station in space work? What are the advantages and drawbacks to this technology? Space-based solar power involves collecting solar energy in space and transferring it to Earth. While the idea itself is not new, recent technological advances have made this prospect more achievable. The space-based solar power system involves a solar power satellite, an enormous spacecraft equipped with solar panels, and these panels generate electricity, which is then wirelessly transmitted to Earth through high-frequency radio waves. A ground antenna called a rectenna is used to convert the radio waves into electricity, which is then delivered to the power grid. A space-based solar power station in orbit is illuminated by the sun 24 hours a day and could therefore generate electricity continuously. This represents an advantage over terrestrial solar power systems on Earth, which can produce electricity only during the day and depend on the weather. With global energy demand projected to increase by nearly 50% by the year 2050, space-based solar power could be key to helping meet the growing demand of the world's energy sector and tackling global temperatures. Some challenges. A space-based solar power station is based on a modular design where a large number of solar modules are assembled by robots in orbit. Transporting all these elements into space is difficult, costly, and will take a toll on the environment. The weight of solar panels is identified as an early challenge, but this has been addressed through the development of ultralight solar cells, a solar panel comprised of smaller solar cells. Space-based solar power is deemed to be technically feasible, primarily because of advances in key technologies, including lightweight solar cells, wireless power transmission, and space robotics. Importantly, assembling even just one space-based solar power station will require many space shuttle launches. Although space-based solar power is designed to reduce carbon emissions in the long run, there are significant emissions associated with space launches as well as costs. Space shuttles are not currently reusable, though companies like SpaceX are working on changing this. Being able to reuse launch systems would significantly reduce the overall cost of space-based solar power. If we manage to successfully build a space-based solar power station, its operation faces several practical challenges as well. Solar panels could be damaged by space debris. Further, panels in space are not shielded by Earth's atmosphere. Being exposed to more intense solar radiation means they will degrade faster than those on Earth, which will reduce the power they are able to generate. The efficiency of wireless power transmission is another issue. Transmitting energy across large distances, in this case from a solar satellite in space to the ground, is difficult. Based on the current technology, only a small fraction of collected solar energy would reach the Earth. A small fraction. Pilot projects are already underway. The Space Solar Power Project in the US is developing high-efficiency solar cells as well as conversion and transmission system optimized for use in space. The U.S. Naval Research Laboratory tested a solar module and power conversion system in space in 2020. Meanwhile, China has announced progress on their Bishan Space Solar Energy Station with the aim to have a functioning system by the year 2035. In the UK, a £17 billion space-based solar power development is deemed to be a viable concept based on the recent Fraser-Nash consultancy report. The project is expected to start with small trials, leading to an operational solar power station in 2040. The solar power station would be 1.7 kilometers in diameter, weighing around 2,000 tons. The terrestrial antenna takes up a lot of space, roughly 6.7 kilometers by 13 kilometers. So that's huge, as you can understand. Given the use of land across the UK, it's more likely to be placed offshore. This satellite would deliver 2 gigawatt of power to the UK. While this is a substantial amount of power, it's a small contribution to the UK's generation capacity, which is around 76 gigawatts. With extremely high initial costs and slow return on investment, the project would need substantial government resources as well as investment from private companies. But as technology advances, the cost of space launch and manufacturing will steadily decrease, and the scale of the project will allow for mass manufacturing, which should drive the cost down somewhat. Whether space-based solar power can help us meet net zero by 2050 remains to be seen. Other technologies like diverse and flexible energy storage, hydrogen, and growth in renewable energy systems are better understood and can be more readily applied. Despite the challenges, space-based solar power is a precursor for exciting research and developing opportunities. In the future, the technology is likely to play an important role in the global energy supply. This is by the conversation on phys.org. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.